We have been looking at the shortest subarray problem adding up to a given target. So for example, the statement is, look, given a list L of positive numbers, find the shortest subarray that adds up to a target T. Now, in the last few videos, we saw an illustration of how we'll solve this, and then we wrote code based on while loop to, let's say, solve this, and looked at it in quite a lot of detail. If you look around internet, if you see search around, you'll find that the more common implementation is based on for loop. And this is what we'll discuss here. The idea is similar to what we saw in the fixed size sliding window, that we have an outer loop for loop, which is controlling one of the two pointers, which is in this case the right pointer. So that's in range n. Makes sense because look, the last item that I can have in, let's say, right is of course the last item, which is n minus 1. Um, you know, um, the left pointer, on the other hand, is controlled from within the loop. So in this case, we need a while loop because look, the window must contract, with the left pointer moving. So basically, what I'm doing is that in every iteration, I move the right pointer. But in some of the iterations, if I've gone above the sum of t, then I start decreasing the left pointer. I start increasing the left pointer. The window keeps contracting. And in that case, basically for a given right, this loop is running several times. So that's why I said it's a little hard to understand that, unlike our other while loop case where every iteration either left moved or right moved. So here, for example, right will move for some time, then it may stay put, and it will, let's say, left will start moving. So the principle is exactly the same as earlier, and the implementation is a bit different, but interesting to look at it. Now, as before, the conditions I'm taking is that, look, if my current sum is becoming strictly more than t, so we spoke about this in detail, strictly more than t, and if my left is less than right? So if these two conditions are fulfilled, I move my left window. Otherwise, I don't come into this loop at all, which means the right pointer keeps moving. Now, once again, let's see this carefully. Basically, while current sum greater than t and left less than right, the way to understand when will I exit this loop? Well, I'll exit this loop when current sum becomes less than or equal to t, or my left becomes equal to right? So both these cases, I'll exit the loop, and which means I'll go back to where I was. Now, notice here that once I, let's say, exit the loop, it could be a point where the sum has become exactly equal to t because this condition no longer holds, and hence I record the ending at the very last, right? So basically the loop runs, either right expands or the left expands, and in the end I record, right? So it seems like just like a mirror or some kind of like a different implementation of the previous solution we have seen, but the conditions are exactly the same. So here I have implemented this solution so that we can see how it's working. Now, in order for us to understand, I put two prints over here. One print outside the while loop and one print inside the while loop. So I just call it outside and inside. Notice for the print that is inside the while loop, I'm putting it at the end because that tells us a clearer picture of how the pointers are moving. Because sometimes this condition may be satisfied in the beginning, but once the sum has been taken, the condition is not satisfied. So I put it at the end. Let's again see this working. So let's say my regular array, when I look at this, the one that the same list that I was looking at, exactly the same. So, you see the pointers are moving. It goes to 0, 4, 11. At this point, you notice I've gone inside the loop. I've gone inside the loop, and you notice that the left pointer is moving. So basically, you can say that the for loop is kind of halting there for the left to catch up, right? So it's very interesting, very nice to look at it. But the philosophy is a little bit, the structure of the code is a bit different, right? But otherwise, exactly the same concept. It runs till the end, and it finds that, look, my minimum range is 3, starting at index 4. Once again, notice at the very end, the right guy has stopped. I've come inside the loop, and I keep doing it until, let's say, I find that I have, violated the condition. So you remember this current sum greater than t, right? So the moment this becomes violated, I exit, and then anyway, the for loop is getting over as well, right? Now let's just also test this against the corner cases. So let's say what happens if I have a 12 to start with. Here, when I run this, once again, I find it because look at this, right? So I am outside 0, 0, 12, even though 12 is more than the sum, right? 12 is more than the sum. I will not get into this loop. I will not get into the while condition because there's an and condition that left less than right? So basically, remember I told you I want to make sure that left is always less than right. So I'll not get into the inside. I will in fact expand the window, and that's exactly what's going on. What happens if I put an 8 over here? Let's say, so if I do put an 8 over here, well, in the very first time I will find it again because current sum is because look, I'll not get into the while loop. However, I'll check for my current sum over here, right? Because current sum is going equal to t, I will in fact record it. So seems quite logical. It's just a mirror of what we had done in the while loop. Once again, if I look at the solutions that are out there, they look a little bit different because the fundamental point of reference is what happens when the sum is exactly equal to t, and hence the code becomes a bit different. But our logic here is quite clear, and I've articulated in detail that look, if the sum is exactly equal, then we will only expand. And that's exactly what we have built through this, right? So once again, think through this, look at the comparison between two codes, think about this, because these structures, these way of thinking will always help you in other problems as well. Happy to discuss. Do look at our website, www.ybyte.in, for more such material and enjoy programming. Take care. Thank you so much. Bye bye.